In this video, we're going to talk about properties and properties of real numbers. Basically, properties are statements that are true for any numbers, for anything. So in other words, these are rules that are universal. Whatever you do within the certain scope, the same rules apply, the same properties apply, and the same you can expect the same results. So they're just steps when simplifying expressions and solving equations. So let's look at the first one, commutative property of addition and multiplication. Basically, what it means is that when you add two numbers together, the order of the values does not matter. So in other words, if I do 2 plus 3, I should equal 3 plus 2. They both comes out to be 5. And if I do 2 times 3, it's 6. And I reverse the order, 3 times 2 is the same. It's also 6, right? But now that you guys in algebra, we do something smarter. We use letters to represent certain terms. Each of the numbers here, 2 and 3, is called a term, and they're separated by either a multiplication or an addition or a subtraction or a division sign. So a term is separated by one of the 4 operations. And again, so in algebra, we say A plus B is the same as B plus A, and A times B is the same as B times A. Order here does not matter. The next property we know or have been working on is called associative property. You've already done all of this. And this property, this is just a fancy name to tell people that grouping of values doesn't matter. So if I have, again, this is applied to addition and subtraction. So let's say if I have 5 plus 1 plus 3, I'm grouping using parentheses. I'm grouping 5 and 1 together. So now I have 6 plus 3 equals 9. But if I do 5 plus 1 plus 3, so now I'm grouping 1 and 3 together. I have 4. 4 plus 5 also equals to 9. So it doesn't matter which way you group. So same thing with addition. I can do 2 times 4 times 7, or I can say 2 times 4 times 7. They both comes out to be the same. And again, this associative property only works for multiplications and addition. And if I have to use letters to represent it, that's going to be the same. A plus B, I use a third letter, C, and it's going to be the same as A plus B plus C. And the other one to do multiplication is A times B first times C is the same as A times if I multiply B and C together first and then multiply by A. Okay? So for these two properties, people often get confused between their names. I just remember that for associations are groups. Therefore, groupings don't matter, right? And commutative means direction doesn't matter. So that's the opposite of, or it's different from associative property. Now, identity property is easy. All it says is that whatever you do, that operation does not change anything. So everything or the answer stays the same. So in other words, it really concerns just our favorite numbers 0 and 1. So A plus 1 is the addition, the identity property for addition. So A plus 0 equals A, right? So it doesn't change my original A. For multiplication, we do A times 1 equals A. Again, that multiplication of 1 does not change anything. Next, let's look at inverse property. Inverse property is really important. I want you to remember this word in inverse right here, because we're going to use a lot of that. What that means is it means opposite. So to use the inverse property is to use opposite. To use opposite to cancel a value. So what do I mean by that is if I do addition, for example, if I have 3 and I want to cancel that value, I do the opposite, minus 3. I would have 0, right? So for multiplication, if I have 3, I multiply the reciprocal, 1/3. I would have 1 now. So that's what it means. And if I express it by letters, I would do A. To do the opposite is negative A to add to it. I now have 0. But if A times its reciprocal, I now have 1. So that's called inverse property. I want you to remember that one. If you don't remember anything, I want you to remember inverse property and distributive property. The rest will take care of itself. Now, property of 0, meaning if you multiply something by 0, you always have the result as 0. So it doesn't matter. You can have 17 times 0 is 0. Any kind of number. You can have a decimal times 0. Any number multiplied by 0. So I'll say A times 0 equals 0. Right? That's the property of 0. Now, distributive property is just like that. You have to distribute the term to every single term in the parentheses. What do I mean by that? I mean you have to multiply a value to an expression inside the parentheses. So if I have 3 times 2 plus 5, if you think about it, 2 plus 5 is 7. 7 times 3 is 21. But if I have to distribute it, I always think about the value outside the parentheses. In this case, is 3. It's like a candy. So if I distribute candy to everybody inside in my classroom, I will make everybody happy. But if one person in my classroom doesn't get the candy, that person is not going to be happy. So notice that this is a multiplication. So it becomes 3 times 2. Then I keep this plus sign here. I add, again, go back to the candy and distribute that to 5. So now I have 2 times 3 is 6. 3 times 5 is 15. I also have 21 when I add them together. So to use algebra, this is what we say. We say A times B plus C equals A times B plus A times C. So that's our distributive property. Like I said, if you don't remember anything else, I want you to remember inverse property and distributive property. And with that, you should be pretty good. Last page, I want to just to cover some new properties. Reflexive property, it just says it's a value. Oops, I wanted to use blue. A value always equals itself. It sounds kind of silly, doesn't it? Always equals itself. So it just means that A equals A. So 16 equals 16. 5x equals 5x, 4y squared equals 4y squared. And of course, that is true. And a symmetric property is almost, it's like how you can flip the things around the equation sign. So in other words, if A equals B, then we can draw the conclusion B equals A. They are the same things. So I say if x equals 3, then 3 equals x, right? If, another example, if 5x equals 30, then 30 equals 5x. Very straightforward. Now the last property, this is an interesting one. It's called a transitive property. So what it says is that if A equals B and B equals C, then A equals C. So let's say if I'm as tall as my sister is as tall as her classmate. So I can say then I am as tall as my sister's classmate. So another math example is if 4 plus 3 equals 7 and 7 equals square root of 49, then we can draw the conclusion that 4 plus 3 equals square root 49. So it gets so this is a term here, 4 plus 3. That's my other term. So first term A gets transferred over to the second term. Notice that this is still my second term, and this is my third term, and my second term gets transferred to my third term. Therefore, I can draw the conclusion that there is an equation sign between my first term and my second term and my third term. Finally, I just want to touch upon this. We haven't really talked about the word set yet, but so it's a little bit challenging. But if you read through it carefully, it actually makes common sense. So it says a set is closed under an operation if the operation always produces an element of the same set. So that's one concept that's called closed. And it is not closed if an element outside the set is produced. So the opposite is called not closed. So what do they mean by that? Let's look at some examples. Here it says integers are closed under multiplication. So I'm talking about integers, I'm talking about multiplication. And it talks about this set is closed, meaning let's do two integers. 2 times 3 equals 6. 2 is an integer, 6 is an integer. What if 2 times negative 5? I have negative 10. I still have integers. So that means whatever operations I'm doing, one of the 4 operations, I'm always having integers. So in this case, this is a closed operation. I'm sorry, a closed set. So this is true, right? We're asked to answer true or false. Second one, natural numbers are closed under subtraction. So my example here would be, okay, if I use 5 minus 4, I end up having negative 4. Negative 4 is a integer, not a natural number. So this one is false. And number 3, the even numbers are closed. Even numbers are closed under addition. That is correct. Number 4, irrational numbers are closed under division. Be very careful. Our favorite number divided by itself, I have 1. That's a counterexample. And 1 is not irrational number, right? So this one is false. Now, perfect squares are closed under subtraction. So if I have 5 perfect square is 25, and 2 perfect square is perfect square of 2 is 4. So you subtract the 2, you get 21, and 21 is not a perfect square. So this is false. So that's the end of Unit 1.2, and I'm going to help everybody in class with the assignments. See you guys. Boys, why are you still talking?